This video will go over how to use the definition of a negative exponent to simplify an expression. So we have three examples up here. The first example, 10 to the negative third, we're going to apply the definition of a negative exponent. A negative exponent says to take the reciprocal of the expression and simplify if possible. So 10 to the negative third is going to be the same as 1 over 10 to the positive 3. Once we take the reciprocal, the negative on the exponent disappears. The negative on the exponent does not have anything to do with the sign of the answer. Now 1 over 10 to the third power, since 10 to the third power is 1,000, we have 1 over 1,000. The second example, I have a negative 5 to the negative 1. Now remember that the negative in front of the 5 is nothing to do with the exponent. So it hangs out there, for lack of a better definition. So think of this as negative 5 to the negative first power. Well, 5 to the negative first power is 1 over 5 to the first power, but we have that negative in front because it was originally a negative. The third example is a fraction itself. So when we take the reciprocal of a fraction, this is what actually happens. We have 1 over the fraction 4 over 9 squared. 4 over 9 squared is the same as 16 over 81. So now we have 1 over 16 over 81, or in other words, 1 divided by the fraction 16 over 81. If you recall that dividing by fractions, we actually change to multiply, and we multiply by the reciprocal. What we really get then is 81 over 16. Now you can take a shortcut here. Instead of doing 1 over 4/9 squared, you could just think of the reciprocal as 9 over 4 to the positive 2 power, and you would still get 81 over 16. The fourth example, mn to the negative 4, two things to consider. Does that exponent apply to the m as well as the n, or not? And what do I do with the negative exponent? Well, we need to consider the first question first. That exponent, negative 4, only applies to the n. So the m remains where it's at. Nothing happens to the m. The n, however, we need to take the reciprocal of that to the negative 4, so we end up with m over n to the fourth power. Now, by contrast, those parentheses in the fifth example make it very clear that the negative 4 exponent belongs to both the m and the n. So we, once again, take the reciprocal. Now, we could leave our answer this way. If you wanted, you could apply that 4 exponent to the m and the n and write it as 1 over m to the fourth, n to the fourth.